Let's briefly talk about how to add two fractions together. I'm going to start with my first example, adding 3/4 and 2/3. In order to add these two fractions together, the key principle is that I have to find a way of making the denominators of both fractions equal. And in this case, looking at the denominators of 4 and 3, I can see that I can turn each of those into a denominator of 12. Now, once I do that, I also have to multiply the numerator by the exact same values that I am multiplying the denominators by. So 3/4 becomes 9/12, that's the equivalent fraction to 3/4, and 2/3 becomes 8/12. And now I can easily add these fractions together because the denominators are the same, and when I do so I get 17/12. Okay, so that one was pretty straightforward. Now, suppose I give you an example though. This one is 5/12, and I want to add 2/15 to it. Now, I could do the same thing I did just a minute ago. I could multiply the top fractions, numerator and denominator, by 15, bottom fractions, numerator and denominator, by 12, and I could go from there. However, I wonder whether or not there might be a smaller number that I could multiply both numerators and denominators of each fraction by and get a smaller equal denominator value. A least common denominator, if you will. Well, it turns out we can do that. So here's the process we do to find the least common denominator. I want the LCD for 12 and 15. And the way we're going to do it is we're going to successively try to divide both numbers at the same time by prime numbers. Now I'm going to start with 2 because I know 2 goes into 12. In fact, it goes in 6 times. However, 2 does not go into 15. So notice what I do is I'm bringing the 15 straight down because 2 doesn't divide into it. And I'm going to try dividing by 2 again. In other words, I'm picking the lowest prime number of 2 and asking myself if it divides into either or both of these numbers. And in this case, it does divide evenly into 6. But again, it does not divide into 15. Now I'm circling that again to show that 2 did not divide into that. At this point, I can't divide either of the numbers, either 3 or 15, by 2, and so at this point, we need to divide by 3. And it turns out 3 goes into 3 one time, 3 goes into 15 5 times, and that's as many times as I can divide by 3. And then lastly, I can divide by 5. 1 is not divisible by 5, so I just bring that on down. 5 divides into 5 one time, and I am now done. Once I have 1s at the bottom of this process, I can now show that my least common denominator is going to be the product of these values. So LCD is equal to 2 times 2 times 3 times 5. And that is equal to 60. So that means I'm going to be turning each of these fractions into something over 60. And I'm going to go ahead and set that up. Now that I have the least common denominator, I know it's going to be 60. Well, it turns out that 12 times 5 is 60. And so I need to multiply numerator and denominator by 5. That gives me 25 over 60. 15 times 4 is equal to 60. So I multiply the numerator and the denominator of the second fraction by 4, I get 8/60. Now I can add both fractions together since they have the same denominator, which is 60. So I have 33 over 60. This can be reduced. I divide by 3. We always reduce our final answers if we can, and I get 11 over 20. So in this brief presentation, I've demonstrated how we can always find the least common denominator for a set of fractions by using the division process, the short division process. And then I also, in my first example, showed that sometimes we can see the least common denominator by inspection.